Okay, now we do the same thing. So we don't have to do the first part because it didn't change. And instead we have friction. So on the segment when there's friction with coefficient mu sub k, before we answer this question, let's answer the question, what's going to happen to the work? The kinetic energy. Who gets it?
Friction.
Does friction do... another clicker tragedy. Does friction do work on the mass, or does mass do work on friction, or what's going on? Does friction do positive work on the mass? Yeah, it tends to slow it down. It tends to remove the energy. But let's just make sure we understand that. So if I isolate this mass, I'm going to have gravity down, normal force up, and frictional force is going to oppose the motion. The motion's to the right, so the frictional force is back to the left, F sub k, and because it's level, we have a very easy expression for F sub k, which will be the normal, it's always the normal force times the coefficient of kinetic friction, but the normal force here is just mg. And it opposes the motion. So the work done by friction is the dot product of F sub k vector and the displacement. I keep going back and forth between S and R. Okay? Now the displacement is this way. And the frictional force is that way, and so therefore this will be negative. So d, the work done by friction, will be equal to the, integrate up. The work done by friction will be the integral of F sub k, which is in the minus x direction, so minus mu sub k mg in the x hat, dot x hat dx. That's the differential ds. And I'm going from, what are my limits? So I'm integrating with respect to x, so I'm going to start at some, let's use the same definition of x, except we sort of can't, because we got rid of this spring, so we're going to call x equals 0 where friction starts. So then we would go from 0 to some x final. And we're going to get minus mu sub k mg times x final minus 0. So it's negative, as it should be. Where does the energy show up? Heat, okay? It shows up as thermal energy in the block and in the rough floor.